So this video will focus on Chapter 7, Section 1. If I look here, it says identify the angles such as acute, right, obtuse, or straight. This one here is a right angle, and that's identified by this little square here. That's a 90-degree angle, so it's right. This one here is larger than 90 degrees if I open it out, so it is an obtuse angle. Oops. This one here, if I open it up, it is less than 90 degrees, therefore it's so cute, it's an acute angle. And then finally, this is a straight line, so it's a straight. And what we want to do is conclude about the angles formed by two intersecting lines today. If I look here, for instance, I want to find an acute, and again, that's just less than 90 degrees. So I'm going to go over here, and I'll go like here and here, so less than 90. A straight angle, of course, goes straight down. A right angle forms a 90-degree angle. An obtuse would mean that my angle is larger than 90 degrees. And it says, what is the measure of an angle formed by the hands of a clock at a given time? So at 9 o'clock, let's just look here for a moment. So at 9 o'clock, that would be a right angle. Let me just use a different color here. So 9 o'clock would be right here. And that would be a right angle. 6 o'clock, that's a straight line. 12 o'clock, that also is a straight line, right? I mean, it's half a line, so I guess I'm not sure what it would be there. But in any case, definitely the 9 and 6 we have down here. That's what they would be. In terms of how we identify angles, you could do it two different ways. I could either see this is angle A right here, or I could say that it's angle FAB. And I'm saying it because it has a point on one side, a point on the other side, and the vertex is what's in the middle. This could be known as angle B or EBD. This angle down here is D or B, and then D, and then E. So whatever's in the middle is always going to be the vertex. So in this case, the D has got to be in the middle. For this one here, since this is angle A, and this could also be angle D, this one here could either be angle FAB, or it could be angle BAF. Either way, it's just that I have to have the vertex in the middle. Next one says, how many angles are formed by the intersecting roads? So I have these two here. If I look, I actually have 4 angles. I have 1, 2, and then I have this one over here, 3, and 4. And what we're going to really start to figure out in this lesson is that these angles here, so this angle here and this angle here, these are called vertical angles. They make little V's, right? And this angle measurement is exactly the same if this is X. This is also X. They're exactly the same. Just as if I look at the other side of it, these are exactly the same. So if this is Y over here, this is also Y. And the total distance around, of course, will be 360 degrees. For any line, if I want to go down this like Oakmont Road, to go from one side to the other, that would be half of a circle, or 180 degrees. So we're going to learn about two different things. We have adjacent angles, and we have vertical angles, and I guess we also have congruent angles, which are kind of the same. So if I look here, I have my adjacent angles, which are like angle 2 and 1. These are right next to each other. So I look here, the 2 and the 1, and actually the two of them that are adjacent will equal 180 degrees, won't they? It forms a straight line. This is saying that angle 2 and 4 are not adjacent because they're not touching. Angle 2 and 3 are. That is also 180 degrees. Angle 1 and 4 are adjacent, but so it has to be next to, so they share a common side and the same vertex. Vertical angles are the other thing here. So if I have like angle 1, it forms that V to angle 3. So this angle measurement here is the same as this angle measurement down here. And those are called vertical angles. And if I measure them, they'll be congruent. Just like these vertical angles over here will also be congruent. So now we're going to go through here and name some pairs of adjacent angles. And there's a couple of them on here. Very first one is ABC. So ABC and ABF. These are adjacent to each other because it has a common vertex and they're right next to each other. I could also say CBD and EBD. Those would also be adjacent angles. A pair of vertical angles, there's only one on here, and that would be from here up, and then also this one over here. So it forms a V, and again, these angle measurements are congruent, meaning they are the same. So it says here, find two pairs of adjacent and two pairs of vertical. So my adjacent again, so like this angle here and this angle here, they have the same focal point here, endpoint, and they are right next to each other. And vertical angles, of course, are directly across from each other. You'll notice that these are not the same measurement. Adjacent angles are not the same, but when I add them together, they will equal 180 degrees. And then for my vertical angles, they are directly across from each other, and they will have the same angle measurement. So if I look here, let's give some examples of this. So I know that the whole thing here is 180 degrees. Therefore, this has got to be 110, because 180 minus 70 is 110. I also know that this has got to be congruent to this vertical angle, so this is 70 degrees. And this must be congruent, so this is 110. If I look down here, I know that altogether, this whole angle has to equal 90 degrees. And I have one angle that is 31 plus x plus 4. And the whole thing equals, again, 90, because it's a right angle. I'm going to add things up, and I'll have x plus 35 equals 90. Subtract the 35 from both sides. And now I'll have x equals 55. Right? Let me just double check that. So if I add this up, I'd have my 8, 90. Yep, so that works. So that's what I get. So x equals 55 degrees, which means this angle down here is equal to 59. Because I'd plug in 55 plus 4 and get 59. So I'll move this all out of the way. Let me just, and that's kind of what we just said. It says here, draw a pair of vertical angles with a measure of 40 degrees. Well, I would just kind of draw my line here. Oops, well, that works. So I can use a protractor, make it 40 degrees. And now I can continue this. I can kind of go like, I can continue this line this way. I can continue this line this way. And this should also be 40 degrees. Of course, if I want to find out the angle measurement of like from here, like what this angle measurement is, from here to here, I can just look at this line and know that this from here all the way around is 180 degrees. If this is 40 degrees, I would take 180 equals 40 plus x, where this is x, right? And I'm subtracting 40 from both sides, and I'll have x equals 140. This one here, it says, tell whether the angles are adjacent or vertical. So if I look here, these two are next to each other, therefore they are adjacent. It's 180 minus 85, so it's 170, I'm sorry, 105. 95, it's 95. This one here, this is going to be a vertical angle, so this will also be 90 degrees. This here is going to be an adjacent angle, and I know the whole thing equals 90 degrees, so I have to do 69 minus 1, which is 68, and 2x, so I take 90 minus 68, which is 22, divided by 2, which is 11. Then I plug it back in. 11 times 2 is 22, minus 1 is 21. So this is what all the measurements are, which is what I just said. The only thing that's different is right here. This x equals 11. And now what is the value of x? This angle was 2 times 11, which is 22, minus 1, which is 21. So that's that. And finally, vertical angles are always congruent. Or I'm sorry, is always acute. Adjacent angles could be acute. Adjacent angles could be obtuse. Vertical angles are congruent, or adjacent angles can be congruent. They're all true with exception to the first one. Vertical angles are not always going to be acute. Sometimes, as I showed before, I have something like this. These vertical angles are totally acute, but these vertical angles here are obtuse. So, and the rest of these are true. And that's the lesson.